Hello friends, we know that electrical current is nothing but the flow of charges. What makes the electrical charges to flow? Are they moving by themselves? Let us consider the analogy of flow of water in a tube. Water do not flow by themselves in a perfectly horizontal tube. If one end of the tube is connected to a tank of water kept at a higher level such that there is a pressure difference between the two ends of the tube, water flow out of the other end of the tube. Here, gravity plays an important role in creating the pressure difference. In case of charges, it do not flow in a copper wire by themselves. The charges flowing in a conducting metallic wire or a copper wire are electrons. The electrons move only if there is a pressure difference or there is a difference of electrical pressure called potential difference along the conductor. This potential difference may be produced by a battery. The chemical action within a battery generates the potential difference across the terminals of the battery or cell even when no current is drawn from it. When the battery is connected to the circuit, the potential difference sets the charges in motion in the circuit and produces an electrical current. In order to maintain the current in a given circuit, the battery has to expend its chemical energy stored in it. We define electrical potential difference between 2 points of an electrical circuit carrying some current as the work done to move a unit charge from one point to another. The potential difference between 2 points is given by work done divided by the charge. If the potential difference is denoted by letter V, work done is denoted by letter W, and the charge is denoted by letter Q, then V is equal to W by Q. The SI unit of electrical potential difference is volt, named after Alessandro Volta, an Italian physicist. 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. Therefore, 1 volt is 1 joule per coulomb. The potential difference is measured by means of an instrument called voltmeter. The voltmeter always connected in parallel across the point between which the potential difference is to be measured. Voltmeter has a high resistance so that it takes negligible current from the circuit. We know that the flow of charges constitute an electrical current. The flow of electrons in a conductor is due to the potential difference between its endpoints. This potential difference is provided by some source, say battery or cell. A battery or cell has two terminals. One is positive terminal and other is a negative terminal. In an electrical circuit, a cell can make electron to move and electrical current to flow. The movement of electron is from negative to positive terminal, but by convention, the direction of current flow is taken from positive to negative terminal or against the direction of flow of negative charges. There must be a conducting path like wire, bulb, etc. between the two terminals of the cell or a battery through which electron can move, and the movement of the electrons causing electrical current to flow. Even though wire, bulb, etc. allow the flow of the electric current through them, they offer some resistance to the flow. A continuous conducting path consisting of wire and other resistance like electric bulb, etc. and switch between the two terminals of a cell or a battery along which electrical current flow is called a circuit. A simple electrical circuit is shown. In the circuit, we have a cell having a positive terminal and a negative terminal. The positive terminal of the cell is connected to the one end of the bulb holder with a copper wire through the switch. The negative terminal of the cell is connected to the other end of the bulb holder. The copper wire connecting 2 points or more elements of an electrical circuit, and this connecting wire is also a part of electrical circuit as it creates a continuous path for current flow. When the switch is closed, the circuit is complete and hence the current flows in this circuit. This current makes the bulb to light up. If we open the switch, then the gap is created between the two ends of the conducting wire. Due to this, one terminal of the battery gets disconnected from the bulb and the current stops flowing in the circuit. Thus, when the switch is opened, the current breaks and no current flows through the bulb. The bulb stops glowing. Let's discuss about symbols for electrical components or circuit symbols. In electrical circuits, we have to show various electrical components such as a cell, a battery, connecting wire, wire joints, fixed resistance or variable resistance, ammeter, voltmeter, galvanometer, an open switch and a closed switch, and an electrical bulb or lamp, etc. Now, to draw the electrical circuit by making the actual sketch of the various electrical components is a difficult job and takes a lot of time. So, the scientists have devised some symbols for electrical components which are easy to draw. These are called electrical symbols or circuit symbols. Now, we will discuss the common electrical symbols for electrical components which are used in drawing circuit diagrams. Let's discuss about cell and battery. Battery or cell is a primary power source for any electronic wireless gadget, be it a smartphone, laptop, watch or a remote. A cell is a single unit device which converts chemical energy into electrical energy. A battery usually consists of a group of cells. A cell is an energy source which can deliver only DC voltage and current which are in very small quantities. For example, if we take the cell we use in watcher or a remote control, it can give a maximum of 1.5 to 3 volt. On the other hand, the functionality of the battery is exactly same as that of the cell, but battery is the pack of cells arranged in a series or parallel fashion so that the voltage can be raised to a desired level. The best known example of battery is a power bank which is used to charge up smartphones. If we ever see the inside of a power bank, we can find the set of cells arranged serially or parallelly based on the requirements. Batteries arranged in a series to increase the voltage and in parallel to increase the current. The symbols for a single cell is shown. The symbol of a single cell consists of two parallel vertical lines, one thin and long and the other thick and short, having horizontal lines on the sides. The longer vertical lines represents the positive terminal of the cell, so it is marked with plus, whereas the short vertical line represents the negative terminal of the cell, so it is marked minus. In order to obtain a battery, the negative terminal of the first cell is joined with the positive terminal of the second cell, and so on. The symbol for battery is shown. The battery shown in the figure consists of two cells joined together in series. We can also draw the symbol for a battery having more than two cells in a similar way. Resistor with a resistance R is an electronic or electrical component that will change the current flowing in a circuit, and the value of the current flowing depends upon the value of the resistor. Resistor with resistance R is an electronic or electrical component that will change the current flowing in a circuit, and the value of the current flowing in the circuit depends on the value of resistance R. The resistance which can be changed as desired is called variable resistance. The variable resistance or resistor has two symbols as shown. The variable resistor is also known as rheostat. Rheostat is a variable resistor which is usually operated by a sliding contact on a long coil made of resistance wire. A rheostat is used to change the current in a circuit without changing the voltage source like the cell or a battery. It can do so by changing the resistance of the circuit. The galvanometer is a current detecting instrument. The symbol of galvanometer is letter G in caps within a circle. The two lines representing the connection leads of the instrument. The ammeter measures the current in a circuit. Ammeter is denoted by the symbol letter A in caps within a circle. The voltmeter measures voltage across any point in the circuit. The voltmeter is denoted by the symbol letter V in caps within a circle. The switch or a plug key is a device used for making or breaking electrical circuit. When the switch is open, the circuit breaks and no current flows. But when the switch is closed, the circuit is made or completed and the current flows. The connecting wire is denoted by a straight line. A joint of 3 or more connection wire is denoted by a dark circle at the point of joint. So far, we have seen symbols used for representing different elements used in electrical circuits. We need some method of representing electrical circuit graphically. For that purpose, we use circuit diagrams. A circuit diagram is a simplified conventional graphical representation of an electrical circuit. An electrical circuit diagram is a diagram which indicates how different components in a circuit have been connected by using electrical symbols for the components. It is called a circuit diagram.